ClickMyProject.com that we discuss about the process a survey on blood vessel detection in retinal images. Let me see the abstract of the process. We propose an algorithm to classify the retinal images as normal or abnormal based on the candidate extraction. The images were first pre-processed to remove the noises in them. For pre-processing, two concepts, illumination equalization and histogram equalization, were employed. Then the candidate extraction is done to find the abnormalities in the pre-processed images. After candidate extraction, the features such as area, mean, standard deviation were extracted. These are all done for the query image and the values were saved as the test features. The same procedure is repeated for all the images in the database and the features were stored as the trained image features. For all the trained images, true labels were set. The test image feature, train image feature and the true labels were passed to the classifier. The classifier matches the test image features with the train image features and find the true label corresponding to the test image and gives us the classification result. We use ANFIS classification in our process. Finally, the performance of the classifier is analyzed. Let me see the flow of the process. Input retinal images were obtained from the dataset. From the retinal images, the green channel is alone extracted. For retinal images, the required informations were present in the green channels only, and hence the green channels were alone extracted. After that, the pre-processing process is employed, which is based on illumination equalization and contrast equalization. In both of the process, the overall intensity of the retinal image is normalized and the regions were brightened so that we can identify the defected portions more effectively. Then we move on to the candidate extraction process. In the candidate extraction process, the blood vessel regions were extracted, which is based on the morphological operations. Morphological operations binarizes the input images and based on the binarized regions, the morphological processes identifies the required portions from the input images and process them. As a result of this, we extract the blood vessel regions from the input images. The next process is the feature extraction process. The statistical features were extracted from the images. Statistical features were more helpful for the identification of the exact parameters from the input medical images, and hence the statistics like mean, standard deviation and entropy were all measured. After that, the classification process is employed, which is based on the ANFIS classifier. The ANFIS classifier classifies the input images and identifies the defects in the images. The classifier is a combination of a neural network and a fuzzy logic process. It from the performance of the process is measured in terms of the accuracy of the process. Let me see the running procedure of the process. If you want to run the code, select the file main.m, which is present in the dataset source code folder. Right click it and click on run file. You will get the process executed. So the first step is the training of the images from the dataset. So after we have clicking the train images, the dataset will be trained and the result will be displayed here. So after the training process has been completed, the values will be displayed here. After that, we select any one of the input image from the dataset. So first, we select the input retinal images from the dataset. After that, we apply the pre-processing process. So in the pre-processing step, the input image is filtered using intensity equalization and the histogram equalization process, and the histogram values in both cases were displayed here. Then after that we extract the candidates, and this is the extracted candidates from the input images. Then we extract the feature values from the data set. After that we classify the input image. So with the feature values extracted, the images were classified. So the input retinal image has been affected by obstruction of vertical circulation. After this process, the performance of the classifier is measured. So the performance of the classifier is calculated based on the accuracy of the process. The accuracy of the classifier is measured, and the level of the disease is also identified. Thus, we have identified the diseases in the input retinal images based on the extracted visual regions from the images. Thanks.